2015 Leaving Cert Higher Level Paper 1 Question 9 is the length of a day in Galway. It's a sinusoidal function. We're told that the approximate length of a day in Galway measured in hours from sunrise to sunset may be calculated using the function f of t is equal to 12.25 plus 4.75 times the sine of 2 pi t over 365, where t is the number of days after March 21st and 2 pi t is measured in radians. So put your calculator into radians for this question and maybe get used to using radian measure. Find the length of the day in Galway on June the 5th, and it tells us that that is 76 days after March 21st, and we want our answer in hours and minutes correct to the nearest minute. Okay, so t is equal to 76. So we're looking for f of 76, which is equal to 12.25 plus 4.75 by the sine of 2 by pi by 76 over 365. That's right, 2 by pi by 76 over, so that's going to be, so in radians this is going to give me the second part 4.587, and I'm adding that to 12.25. That's going to give me 16.837, and that's a decimal of an hour. And if I multiply 0.837 by 60 to get the minutes, I get 50.22 minutes. So we're looking at 16 hours, 50 minutes. Part B, find the date when the length is 15 hours. So we need t, we need the time or the amount of days. And then we need to add it to March the 21st. So we need to know how many days are in March. So the whole function is equal to 15. So f of t is equal to 15. We're looking for t. So 12.25 plus 4.75 by the sine of 2 pi t over 365 is equal to 15. So we can get the sine of 2 pi t over 365 is going to be 15 minus the 12.25 divided by 4.75. That's going to give me 2.75 over 4.75. 25 goes into these, doesn't it? 4, 5, 6, 8, 11 over 19 will simplify down as 11 over 19. The sine of 2 pi t over 365 is equal to 11 over 19. So leaving your calculator in radians, if we get the inverse sine over 11 over 19, it will tell us what this is equal to. So the inverse sine of 11 over 19 is equal to 0.61743, 0.6174 will probably do. So we can say that 2 pi t over 365, now pi has come outside the angle now, so it's not going to be 180, it's going to be radians, so we're still dealing with 3.14. That's equal to 0.6174. So simplifying down to get t, 365 by 0.6174 would be equal to 2 pi t. So just cancel your 2 pi t and divide by it, or divide across by 2 pi t. We'll get t is equal to 35.87. Now we can't, the days, we're going to have to have a full day here, so we round up to 36 days. So 30 days have September, April, June and November, all the rest of 31. So 31 in March. I wish I knew that without having to do the rhyme. And the 21st of March, so we've 10 days in March, which would leave how many days in April? Another 26. So 26 days in April will get us all the way to the 26th of April. That's part B. Part C is find the derivative of f of t, f prime t. So f of t is either 4.75, no, 12.25 plus 4.75, 12.25 plus 4.75 by the sine of 2 pi t over 365. Now, when we differentiate sine, it goes to cos. So f prime t, there's no t here, so that's going to go to 0. So we're just going to be left with 4.75 by the cos of this angle, 2 pi t over 365. And if the angle was 5t, it would differentiate to 5, so it just becomes the constant in front of t, which in this case, we're going to multiply with a differentiated angle of 2 pi over 365, the constant in front of t. So we can probably tidy that up a bit, because we're only asked for the derivative, so do it in simple form. 2 pi by 4.75 is 9.5 pi, and the 365 is on the bottom, by the cos of 2 pi t over 365. So that's it in as simple form as you can get it. Part D, hence or otherwise find the length of the longest day in Galway. Okay, let me just highlight f of t here. So this is just a little bit of basic knowledge that you guys all have about sine and cosine functions. Sine max is equal to 1. So the sine min is equal to -1. So the shortest day and the longest day would be 12.25 plus 4.75 is going to be the max, because 4.75, the max value this can be is 1. So 12.25 plus 4.75 will be the max. And that's going to give me 16 and 1, 17 hours. We may as well write the min value down here. The min value will be 12.25 minus 4.75, which will be 11.5 minus 4. That is 7.5 hours. So big difference between the longest and shortest days here. Part E of this question, the final part, we're asked to use integration to find the average length of a day. Once you see average length, your brain jumps out 1 over b minus a. Over the 6 months, from March 21st to September 21st, that's 184 days. So it's going to be 1 over 184. Well, the minus 0 is not needed. And give your answer in hours and minutes correct to the nearest minute. Okay, let's write down f of t and then integrate it. F of t is 12.25 plus 4.75 by the sine of 2 pi t over 365. Okay, cos differentiates to be minus sine, so sine integrates to be minus cos. So we're going to also get, so we're looking for the integral. Let's integrate it first, then we can put our limits in then. The integral of this whole thing will be equal to 12. Well, I'll write it down like this. I'll write it long form. 12.25 plus 4.75 sine of 2 pi t over 365 dt. And it's going to be between 184 and 0. So we're going to get 1 over b minus a. So we're going to get 1 over 184 times 12.25 is going to become 12.25t. We said sine goes to minus cos, so we're going to get minus 4.75 by the cos of 2 pi t over 365. And the bit to remember in this case, this is like cos ax or sine ax if we started with sine. So you have to go and multiply it by 1 over a when you're integrating. So that's going to be times 1 over a is the constant in front of t, 2 pi over 365. Now 1 over 2 pi over 365, if we turn that fraction upside down and multiply, we're going to get 1 times 365 over 2 pi. So in this case it actually inverts. So we're going to get the limits there, 184 to 0. So we're going to get 1 over 184 by 12.25t minus, we said 365 over 2 pi. So 365 over 2 pi by 4.75 cos 2 pi t over 365. And now we need to put our values in. So putting 184 in first, we're going to get 12.25 by 184, which is 2254. Putting this whole thing in, I'd start with cos. I'd say cos and use your AB function on the calculator, 2 by pi by 184 AB, and then drop the 365 down to the bottom of the fraction, multiply by 4.75 by 365 and divide by 2 pi, and you're going to get minus 275.84, but this minus is going to make it a plus, so plus 275.842, so 84. So then if we put 0 in, so it's always minus, and actually I need to double bracket there, but I'm putting that second bracket in. So minus, if we put 0 in here for t, we're going to get it as 0. And then the cos from your unit circle knowledge, even with radians, the cos of 0 is equal to 1 to 0.10. So this is just going to give me a value of 1. So it's just this guy here that we need to worry about. 365 by 4.75 divided by 2 pi, it's going to give me a value of 275.934. 275.934, and you can see the two minuses here, and I have that double bracket, so put a double bracket on this as well if I need to. So we're going to get 1 over 184 times, so it's going to be times 2254 plus 275.84, and then another plus here with these two minuses. It's going to give me a value of 2805 and 777. And if I divide that by 184, I'm going to get 15.25. I could round this off to 25 hours. And actually that works out evenly. It's a quarter of an hour. So we're going to get 15 hours, 15 minutes. Now, what did I can't even remember what they asked us at the beginning. It was so long ago. Okay. The average length of a day. Okay, so we're looking at the average length of a day here. 15 hours, 15 minutes over the course of 2 months in Galway.